Hey guys, good evening. I hope I'm pretty much audible as well as visible. So I think we are good to start. Okay, welcome to everybody here. Thank you so much for joining again. So today we will be talking to our next topic, which is classification indexes. So we talked about the regression indexes in our last class, where we saw how a regression problem can be assessed, and we figure out the different data pointers there for regression indexes. So we saw mean absolute error, mean square error, and root mean square errors, everything. So all of these parts were pretty much getting used for our discussions in the regression indexes. Likewise, the classification sort of a problem, which is again part of the data set here, which is where we say, or from the use cases where we talk about the yes, no, 0, 1, true, false, more like a classification where we have different classes coming into picture. So how this works and how this is getting used. So this is pretty much what our agenda today is, to identify how the classification indexes gets identified, right? So we will be discussing this today, and we'll try to identify the different classification indexes we have and how this is used for our purpose. So we'll go in detail in the classification index. Cool, guys. So that's pretty much what we intend to talk. So if you quickly remember, we have been talking about the supervised method, or the machine learning stats, where we have the supervised problem where we have the labels, right? So we talked about labels, and then again, so we talked about two types of labels. So we were talking about supervised method. So in the supervised method, we have two methods. One is a regression problem, so where a label is a continuous number, right? So we talk about a continuous number. Examples would be like a salary, or what to say, price, sales. So all of these would be my example of regression type of a problem. Second would be a classification type of a problem, where we say label is a class. Class as in 0, 1, true, false, yes, no, right? So all of these are pretty much coming under the classification type, and that is where we will be evaluating. So how these individual classes, that's what we have, will be assessed in our problem statement. So that's what the agenda is for today. So we will be discussing on that front as well. So let's get started. Before moving, my name is Arpit Jain, and the reason I'm here because data science is my true passion, guys, and I really like sharing my expertise with people. So where I have almost about a number of years of experience in analytics into multiple different sectors. And along with that, I'm also a motivational speaker. So I do talk to students regarding their career, job placements. And since it's pretty much a live session, so we are live here, and I'm monitoring the chat as well. So any questions, anything, I'm more than happy to answer, guys. So please feel free to put in your questions, queries in the text, and we will try to take that. Okay. So guys, apologies. I think there was a network issue at my end. I hope it is fine now. Yeah. Okay, looks good. So that's what I said. So this is about me. It's pretty much a live session, guys. So please feel free to put in your comments or questions to that. So I'll try to address that, right? So moving forward ahead, is agenda. So we will be talking about machine learning. So machine learning, that's pretty much what we'll take a quick look at. So we have seen the different type of problem statements. So we'll first understand again a quick recap of machine learning. So what machine learning is, the different types of problem statements and how do we use it. So that's pretty much, we are going to talk about the machine learning stuff. And then we'll quickly move towards the classification indexes, where we will be talking about prominently something called as confusion matrix, right? So confusion matrix is the one which is prominently, I would say, the part which should be explored, and there's a lot of confusion around this area, and then we try to understand what is a confusion matrix, right? So in confusion matrix, a lot of keywords come called as type 1 error. We're going to look into that. Then we have type 2 error, and then we're going to look into that as well. And then post type 1 and type 2 error, we will be focusing towards some metrics, which is like precision. We're going to talk about recall. We're going to talk about F1 score. And then there's again something called as accuracy, right? So all of these four, we will be discussing around this confusion matrix in detail, and we'll try to explain with examples as well. So we'll look into this. Cool, guys. So that's pretty much what the agenda says, but moving forward, just a quick recap about this. So you know, artificial intelligence is a set of algorithms and intelligence to try to mimic the human intelligence, where we say that the AI is nothing but a set of algorithms which is trying to mimic my human brain, right? And you know, a human brain can do a lot of different things. Like I can do possibly everything here, like a normal human brain, right? So the intent towards using this artificial intelligence is to mimic what exactly a human can do here, right? So the objective is, with a set of certain rules and algorithms and whatnot, we are trying to mimic the intelligence of a human brain onto a machine. So machine is going to do from a human intelligence point of view. That is where artificial intelligence comes into picture, right? Machine learning is one of them. So machine learning is one of the methods of artificial intelligence. So where we talked about AI broadly are of two types, where we say something called as strong AI, and there's something called as weak AI. So strong AI, where we have artificial general intelligence or robotics. And in weak AI, we talk about machine learning, where deep learning is again a sub part of machine learning, right? So machine learning is one of them, one of the types of artificial intelligence, and deep learning is one of those machine learning techniques. So deep learning is not a separate entity, guys, often regarded as a separate entity, but no, it is again another sub part. Is one of the sub part of artificial intelligence, and deep learning is another part of machine learning itself. Okay, quick recap of my machine learning. So we have already studied this. So machine learning, what it is, nothing but it is including a section of AI. So we're going to talk about certain section of AI, and deep learning is a part of machine learning. So we saw that. So again, quickly recapping this. So AI, as I've told you, two types here. One is my strong AI. That's where we have robotics coming into picture. And then another is weak AI, where the objective is, why it is called a weak AI? Objective is very single problem, right? So single problem only we're trying to solve. Where in strong AI, it is more like multiple problems at the same time, where we mimic the brain, right? So basically, we're trying to look at solving the human brain here. So that's where strong AI comes into picture. Weak AI, we are prominently looking at solving a single problem at one point of time. So that is where weak AI comes into picture. So that is what we're going to look at. And then Objective here is prominently to learn the data and give the meaningful business outcome. So we are trying to say that we are trying to understand the data which we have, and from this we're trying to understand the pattern. So more prominently we're going to say that yes, we have been doing this data processing, and then from this we're trying to understand how basically the data patterns look like. So from the available information we're trying to understand the data, understanding the meaningful insights of it. We're trying to get the pattern, and with this pattern recognition, we're trying to generalize this and trying to get a possible outcome, right? So that is where, right? So once the pattern has been identified, what it is referring to. We took one example also in the last class where we saw that, suppose you go to a doctor and then you have say a particular disease. So he might be looking at a lot of symptoms, symptom 1, symptom 2. He might be looking for certain reports, right? So reports, again, where we'll be having a certain report of things, certain parameters, report 1, report 2, and all that. And the combination of everything eventually is turning out to be your pointers. It is turning out to be, yes. So with this, now we are sure that if we have these many symptoms and if we have these many patterns of my problem statement, then this, yes, this relates, you might have a disease A. So how come this is getting identified? So basically it's a pattern between my symptoms and the reports, which is indicating that the person is having a disease A. That is where now, instead of a human doing the same thing, we are trying to mimic a similar activity which can be performed by a machine. That's where we're going to say the pattern recognition, right? So pattern recognition again is a very broad term, where from the data now we are trying to understand the different patterns and trying to see how we can use this for a particular business purpose here, right? So basically we are trying to have the ability to recognize the patterns in the data, like the way I've told you. This can be used for any business perspective. It's not only limited to a healthcare industry. Any industry, any business case, any problem statement where we have certain relationship between my features or the certain parameters, and that is related to a certain output. So we're going to identify that pattern, and accordingly we're going to find out the details for that. And this is where we are subjected to train this pattern. So objective is that the pattern should be trained and we could show the output in the desirable manner. So these patterns should be trained to show the output in the desirable manner. So that is what we are supposed to find out. So this patterns is very important, right? So ultimately with the help of this pattern itself, we will be saying that yes, now we are up to something, and this is what it is referring to. Cool. Moving ahead. So we know that two types of machine learning methods, supervised and unsupervised method, right? So two different machine learning methodologies, supervised training and unsupervised training. So as the name suggests, is a very prominently asked question. So supervised training, as you know, something which is in supervision. And by supervision, we mean that when we are trying to do a pattern identification, at the time of pattern identification, we are trying to identify the relationship between my individual symptoms, like what say feature set, with target, which is my disease. So symptoms is having a relationship with my disease, right? So that is what we're going to look at, and that is what it is important as well. Supervised learning, that is where we're going to say that each of these symptoms is now related to my disease. So a feature set is actually related with my target. So a data set where we have the target or the labels available, we're going to say that this is nothing but a supervised method. Unsupervised method is the one where I do not have any supervision, or I do not have any labels there. By label, again, I mean the target variables are not there. So basically we could say that yes, I might have the things which is more like the dependent variables and nothing on the target side. I could have that. So falling under the unsupervised method. So we will be taking unsupervised method separately, but now in the supervised method, going in detail. So what we discussed, this method or the learning algorithm takes the training data and it is associated output, that is labels or responses. So we have a data set, suppose like this. Right? So I have, say, patient ID. I have symptom 1, symptom 2, report 1, and I have disease. Whether he has disease or not, yes or no. Patient ID 1, patient ID 2, symptom 1 is say yes, symptom 2 is no, report 1 is say 100, this is no, this is no, 100, this is say 77. So this is for this patient ID, yes, he has disease, and for him, he doesn't have disease, right? So these all data sets is directly related with my disease. So with symptom 1, yes, with symptom 2, no. R1 is, report 1 value is 100, yes, this shows that the person is having the disease. So this is, it is directly related to my value in my output. Right, so this method or the learning algorithm take the training data and its associated output, the labels or the responses during the training process. So the main objective of supervised learning algorithm is to learn an association between my input data samples and the corresponding outputs. So whatever my input data points are, which is in this case yes, no, 100, it is directly correlated with my output, which is nothing but having the disease, right? This is where a supervised method or a problem of classification comes into picture. So broadly, supervised is of two types, classification and regression. So we have regression where we have the famous numbers. Now we are talking about a class, more like yes, no, or true, false, or say 1, 0. So all of these individual subclasses, that's what we're going to look at coming under the classification type here. And now, based on the agenda of what we're trying to look at, from this classification, how we should be looking at the classification indexes. So now I have the model available with me, and I mean the training has happened from the input parameters and the output, which is nothing but a class label like 1, 0 for me. So how come this is interconnected? So how can we say that now my learning which has happened is correct, or the output which I'm seeing right now is correct? That is something which is very important, and that is where the confusion matrix comes, guys. So this is all the story behind the confusion matrix. Now let's jump into the confusion matrix. So as the name suggests, it is a matrix which is confusing. Yes, it is slightly confusing. So we'll try to look into this, okay? So before even jumping into this, let's try to understand. So I have a training data, okay? I have patient ID 1, patient ID 2, patient ID 3, patient ID 4, patient ID 5. And for each of them, I have a label, like a true label, or the actual label, or I just rename it. I'll call this as actual label. Okay. So actually this person, suppose he has disease, this he does not have disease, he has disease, he has disease, and he does not have disease. So now each of these patient IDs, I am having the actual labels, yes, no, yes, correct? I would have trained my model and I would have tried to test now. So I would have also the predicted label, where after the learning process, after the ML algorithm has been trained, I have the prediction results as well, where I will be saying that, okay, now the patient 1, which was actually yes, my model is also saying yes for him. Now the patient ID 2, actually he was no, but now the model is saying yes for him. Now this patient is yes, for him it is saying no. Now the patient is yes, it is again saying yes. And the patient is no, for him it is saying no. Yes. So now can you see this? There are differences here. So for patient number 1, actually he was yes. By learning process also we are able to identify this as yes. Fair enough. But now can you see this? For patient ID 2, originally this patient was not having disease, but my label got identified as yes. This is wrong. Vice versa. Now originally patient is having the disease, but I am not able to detect it. Again, even this is wrong, but these are two different type of errors. Originally it was no, I predicted yes. Here originally it is wrong, definitely they both are wrong, but there are two different types of wrong which we could see. We'll discuss in detail about that. And for others it is perfectly fine. Yes, no, it is perfectly fine. So now for each of them, we are trying to count the confusion matrix is nothing but the count of occurrences between each of these actual and the predicted part. So the same thing if I want to represent in a confusion matrix format, I'm going to remove this. I'm going to show you how does it look like. So now look at this. On the top, you are seeing the actual part, and in the left side, you are seeing the predicted part. And for both of them, actual, we had what? We had yes and no, or also say 1 or 0. Likewise, for predicted, also we have two parts, yes and no, or 1 or 0. We can say that, correct? And this 1 is nothing but represented here as positive, and this 0 or no is getting represented as negative here. So you can see the predicted values. So these one, yes, no, it is nothing but positives and negatives. So considering the 1 as my positive and 0 as my negative. Likewise, same for actual also. So on the top you can see 1 and positive and negative. Finding the grid of my positives and the negatives here. Let's try to understand. So we had situations where actually the patient was yes, having the disease, and we also say it is predicted yes. So actually yes or 1, so this case, and predicted also 1. So this is the grid we are talking about here. So it is true positive. So this TP is nothing but true positive. How do we infer this? So this is my positive. So this P is always referred from the predicted side. So it is predicted positive, and this 2 from the actual side. So TP, the second term, is from the predicted side. Actual side. So I predicted positive, and this positive is true. I predicted this patient as having the disease as positive 1, and also originally this is true. So my prediction is true. You're getting it? So my positive prediction is true. That is where it is called as true positive. So infer, if I have to say true positive, positive prediction is true. That's what it means. Clear? Right? Now moving ahead for the next part. I'm gonna remove this. Second is, now we're gonna say that this part, FP, false positive. So I predicted as 1, so still FP, second is, I predicted 1, so I predicted this guy as positive. So my prediction is yes, but originally this guy was no. I predicted that this guy is having a disease, but this prediction of my positive 1, positive yes, is wrong. It is not correct. So this guy is not having the disease. So originally it was 0. So it is false. So positive prediction, which is wrong. I have false positive here. Now likewise, false negative. So this Fn is nothing but false negative. So this N negative is from prediction. So I predicted this guy as negative. So I predicted this guy as negative, no, but originally he had the issue. He had the disease. So this means, just a small correction here again. So this means negative prediction which is wrong. And then last we have Tn, negative prediction which is true. So I predicted this guy as not having disease. Yes, and originally also he does not have a disease. So true negative. So these 4 matrices are very important, guys. So we have to understand what do we mean by all of these individual terms. So we talk about true positive, we talk about false positive, we talk about true negative, we talk about false negative. So FP, false positive, predicted positive but false. Fn, predicted negative but false. Tn, predicted negative but true. TP, predicted positive but true. Clear? And if you could imagine, these two are my 2 different type of errors we were looking at. So originally it was no, but predicted yes. But originally yes, we predicted no. These are my 2 different type of errors, FP and Fn, right? So we're gonna go in detail about it as well. So how do we use it? How is getting used in my indexes? So we're gonna be looking at that as well. And that is where now each of these individual terminologies comes into picture. So actual values, predicted values, then we have true positive, false positive, true negative, false negative. So all of these individual matrices are important for me and they are getting rectified. So now let's try to identify how this is getting used. Let's take a realistic example. Right. So I have the actual values here and I have the predicted values here. So first grid 1. So the first I'm saying as actual and second I'm saying as predicted. Okay. So both are 1, 1. So predicted is 1. It is true. That means it is true positive. That means this case. So I have a doctor here and she is saying that yes, you are pregnant, and yes, that is true. She is actually pregnant. She is pregnant. Right? So my diagnosis says that she is pregnant, and also yes, it is true. She is pregnant. So case 1. Now case 2, actual it is 0, but I predicted as 1. So doctor is saying that, hey, to this man, hey man, you are pregnant. So he is diagnosing him as pregnant, positive, but originally he is not pregnant. He cannot be pregnant. So this is, he is not pregnant. So the case of false positive is also called as type 1 error. Can you see this? This case of false positive is also called as type 1 error. That means the case where we say that I have predicted as one class, but on a reality that is not the case. Right? That is where we're going to be finding out it is as false positive. Cool. So would be happy to take any questions if there is any, guys. Okay. So fair enough. Proceeding further. Next case is case 3, where it is I have originally said 0, but actually is 1. So I said that you are not pregnant. So I have predicted as negative, but this negative is wrong. So it is false negative. So she is actually pregnant. So again, it's a problematic thing. So situation of false negative is also termed as type 2. And the next is true negative. You are not pregnant. So yes, so this doctor is saying to this man that you are not pregnant. Yes, actually he is not pregnant. That is true. That is true negative. So both are 0, 0. So these are my broad 4 cases where I'm going to find out, that my true positive, false positive, true negative, and false negative. In fact, Mahesh, both are dangerous. Both are dangerous. See, think from this perspective. I'll tell you a very realistic example. Suppose, yes, type 2 is definitely problematic. I say that you are not pregnant. That means, suppose I'm going to say that I'm going to find out whether that person is having cancer or not. So I could not detect his cancer, right? I'm saying that he's not having cancer, but he is having cancer. So basically, we will not be able to give him the medicines on time. He will die eventually because my diagnosis had a problem. Even type 1 is a problematic thing. Look about this. He does not have cancer, but I diagnosed him as that he is having cancer. I started his chemo and I started all the medicines. Even that is dangerous. Even he will die post that. Do you think it is advisable? So both of these situations are actually not an ideal thing. So type 1 error, type 2 error, they both are dangerous. They both are having one or the other problems in their respective industry. So if you go in industry, right, both of them are considered as a problematic thing, and eventually we try to take both of them with their respective importances. So depending on the use case, the problem statement, we define our objective and we see which one is ideal one. But yeah, good point. Right. Chalo, moving ahead. So now, how to use these matrices for our calculation purpose, right? So we have identified. So practically, if you could see, we have 4 things from this confusion matrix. So what is this confusion matrix giving us? It is giving us 4 things. 1, true positive. 2nd, false positive. 3rd, true negative. 4th, false negative. Right? So this is what we are getting from my confusion matrix. True positive, true negative, false positive, false negative. So count of all of these occurrences. If I have multiple patients, I'm trying to identify how many of those patients are falling in my true positive category, for which I have predicted them as positive, and also they are true. They are correct. That predicted one is actually correct. So likewise for false positive, true negative, false negative as well. Now, from the calculation standpoint of view, there are 3 to 4 metrics which we calculate on top of these confusion matrix. Okay. First is precision. So precision, as the term also suggests, it says in a simple language, out of all predicted cases, how many are correct? That is what a definition of precision means. Not a bookish definition, just a logical definition. So out of all the predicted cases, how many times I am correct? So now let's go back to this simple slide. Okay, I'm going to remove the ink from here. Just a minute. Okay, now let's try to see this. So what is my predicted class here? So this is what I have predicted as positive, right? So basically these two are my, can we say, total predictions positive, total predictions class 1, can we say that? And sum of these two, can we say total predictions class 0, right? So if I have to find out the total predicted positive is what? TP plus FP, can we say that? So I have predicted positive, whether it is true or false, I'm trying to find out how many out of them I have predicted as positive. Apologies guys, I think there was a network issue at my end, so got disconnected a bit. Yeah, coming back guys, coming back. So now we were talking about the total predicted positive. So all the positive, whether it is true or false, I'm trying to take a sum of it, right? So TP plus FP is my total predicted positive. Likewise, when I say total predicted negative is what? Fn plus Tn. So I have predicted negative, whether it is true or false, I'm least bothered, but I'm taking the total prediction of my negative class. So Fn plus Tn is my total predicted negative. Correct? That's what I have. So now this is my total predicted cases. So now go back to my definition. So what are the prediction definition says? Out of all the predicted cases, how many are correct? Right? So how many are predicted true cases for me? True positive plus false positive, right? So we say total, this is my total, right? We just identified total predicted positive. It is true positive plus false positive. And out of all the predicted cases, and now I'm saying how many are correct. How many of them are correct? TP. So TP by TP plus FP. You're getting it? So precision is pretty simple, where we say that out of all the predicted cases, which is nothing but TP plus FP, which is nothing but again sum of all the predicted cases, whether it is positive or negative. Out of them, I'm trying to find the ratio of true positives on top of that. Suppose, example, I have 10 positive classes, right? So out of which true positive is say 6, false positive is 4. So what is my precision? It is nothing but 6 by 10. So out of total predicted positive, only 6 times I am correct. So my precision is 6 by 10. Make sense, everybody? Right? So this is how precision is given. Moving forward, the next very important is recall. Right? Recall, in a simple term, would say out of all available cases, how many are correct? So now there's a difference here. In precision, we were talking about out of all the predicted cases, but in recall, we are talking about out of all available cases. So what is my available cases here? Available cases is nothing from calculation of my actual part. Now let's go back here again. Now let's try to see. So we found out total predicted class sum of horizontal, which is TP plus FP. Now, but what are my available cases here? For actual positives, we have what? I'm just going to change the ink here, guys. Just a minute. Okay. So for the actual positives, which is this one, now we're going to say that the sum of TP plus Fn, because this is what the actual ones are, right? So now we're going to say that instead of, I'm going to erase this part. Oh, sorry, my bad. I should have kept it still. Okay, fine. Remove it. Now, so this TP plus Fn is nothing but total actual or available positive case, out of which I have to identify all of them to be correct. This is what my total actual case is. Likewise, this is nothing but total available or actual negative case. Make sense? So this is what my positive case is, and this is what my negative case is. So positive and negative, total actual positive and total actual negative, we are trying to look at. So now coming back, so look at this. What is my definition? So total available negative would be what? TP plus Fn. So positive would be TP plus Fn. Likewise, total available negative would be what? Fp plus Tn. Make sense? So once you draw your confusion matrix, right, it becomes very simple. But again, at the same time, if you try to mug up all these, then it becomes a little tricky. Correct? So this total available negative would be Fp plus Tn. This is simple. Now, if you go back to our slide of recall, so we saw that it is nothing but out of all the available cases. So what is the definition? What is my total available positive class? Would be what? TP plus Fn. We've already seen that. So out of this, how many are correct? So correct is always TP, right? So TP by TP plus Fn becomes my recall. Just the two different representation of my matrices. So first we're going to say out of all the available case, out of all the predicted cases, which is nothing but true positive plus false positive, how many times I'm correct? So true positive out of the ratio. But for the recall, we are saying out of all the available cases or the actual cases, how many are correct? So true positive and the false negative are my actual cases of 1, right? And out of them, I'm only correct the true positive times. That is what your recall means. Cool. So moving ahead, the next, what we call as is my accuracy. Accuracy in a simple term, we say total true predictions of all predictions. So basically, out of all my predictions, what is my all predictions? My all the four matrix, TP, FN, TN, FP. So all my matrix, these are my four predictions, right? These are my four predicted values. So out of all the predicted cases, whether it is false or whether it is true, I'm least bothered with that. Out of all the predicted cases, how many times I am correct? Correct means whether it is true or whether it is positive or whether it is negative, I'm least bothered. I'm only looking for the true cases, all the true cases. So my total predictions would become this: TP plus FP plus FN plus TN, my total predictions, and out of them, I'm only going to look at the true cases. So TP plus TN. That is nothing but my accuracy means. So out of all the available predictions, how many of that is correct? So TP plus TN divided by all the predictions, that's what I have, is basically what my accuracy means. Clear? Last, we have the F1 score or the F measure. This is nothing but a harmonic recall. So it's like an harmonic mean of precision and recall formula. You have seen this. So 2 multiplied by recall multiplied by precision divided by recall plus precision. So simple harmonic mean of precision and recall. So basically covering both the type 1 and the type 2 error. That's where F1 score comes into picture. Right? So harmonic mean, where we say that both the type 1 error and the type 2 error are being considered. So where precision and recall both are considered for the harmonic mean, where F measure comes into picture. Cool, guys. So with this, I'm pretty much done what I intended to cover today. So this is what classification matrix you should be looking at. Any questions is more than welcome, but I'm done with the content. So hope you might have understood both the regression as well as the classification indexes. So this is again one of the very crucial topics of machine learning. Is always about, once we have built up the model, how you're going to evaluate that. That's where these indexes comes into picture, guys. Cool. So any questions, I'm more than happy to take it. If not, then we can wrap up our discussion. I'm going to wait for like a minute or so. If there's any question, I'll be more than happy to take it. Can we have a third class? Yes, yes. We are good. I mean, we are anyway going to meet next week, similar timing. So then we're going to start with now, because we have so many matrices, right? So how to select which one? So we're going to talk about different set of things, so different set of use cases there, right? So and then we're going to be looking at how to choose which metric is ideal for which case. So we're going to be discussing about a practical problems there. How many classes planned? At least I think 10 more videos. That's what I want to look at. But depends on how we're gonna how the viewership is. हाँ जी शुभम, प्लीज बताएं. Data science projects Kaggle पे देख सकते हैं आप. So there are so many open projects available on Kaggle with available data. So Kaggle I think would be the right source for you, where you can go and solve some projects, and that should be good to mention in your resume as well. So that should help. Any other questions, guys? Data science project. Cool. Thank you so much, guys. So, okay, one more question and one thing. The values, how we select that, it will be removed with mean or mode. That is very subjective. See, lot many. It's not only about mean or mode or median. We can do zero filling, 900 filling, any random value also you can fill up, right? So it's all about your intuition about the data, right? But generally everything has a logic. So for example, if it's a time series data, forward filling would be the ideal method, maybe a group by also. If the data distribution is say normal, maybe mean imputation would be good. If it is skewed, maybe median would be better, right? More generally used towards my class of discrete data set. So everything has a logic behind that, Shubham, right? So don't think it from a robot perspective. Try to have the logic behind this, like why am I doing this and what will change if I do it like this, right? So try to think around in that direction. If it is Q, maybe median would be. Yeah, definitely. So we can do that, no problem at all in it. So we can do a case study. So that's plan. Okay, cool. With this, guys, thank you so much. I hope I answered your question, Shubham and Mahesh. So that's great, guys. See you in the next video. Till then, stay safe and be happy. Keep learning. See you in the next one, guys.